In this recording, we're going to talk about digital field device simulator. We sell these kits. We used to sell them pre-built, but mostly kits, for these two field device simulators, a digital and an analog. The digital field device simulator has switch circuits, 6 of them. You can control 6 screw terminal inputs on your controller, and then it's got 6 LEDs that are connected to 6 outputs on your controller. And we call this a universal field device simulator, digital, because you could hook it up to anybody's PLC. And we're going to do the same thing with ignition. We're going to create a screen that does the exact same thing, and it's also universal because you can drag in tags from any PLC to animate and activate these objects on the screen. This is the lab page that we're on, roughly, page 69, and in your lab manual, I had you create these 6 sections right here, and I took you through step by step how to do it, and then I had you add logic. We have to have this logic in the controller because we want to integrate the toggle switch with a momentary push button. The digital field device simulator that you saw here, up here in the corner, each toggle switch is part of a circuit with the momentary push button immediately adjacent to it. That red push button up there is a single pole double throw. So right now you have a common, a normally open, normally closed. And then the toggle switch, you have a common, then you have an up position and a down position. They are wired in a common circuit. If you have the switch, the toggle switch down, which you see over here in our image, if it's down, then that switch is in the off position, but the push button, if you push it, will make it momentary on. If you flip the toggle switch up, then it's on all the time, and when you push the button, it interrupts it. The push button behaves like a normally closed. I call this a 4-state input because you can flip this up and it's maintained on, flip it down, it's maintained off. But if it's maintained off and you push the button, it goes on. If it's maintained on and you push the button, then the input goes off. And rather than animate this square that says push button to copy this LED backlit push button over here, it's a lot more work to animate the whole square because typically you animate the border. If you push the button, the border changes state, changes color. We don't want to do that. We're going to add an additional 2-state multi-state indicator here that will show you if that input is on or off. If you flip the switch up, that should go on. If you push the button, it should go off. If you flip it down, input 00 should be off, and if you push the button, then it goes on. Let's look at the logic required to do this in your controller, because we have to take these, all 4 of these right here, and combine it into a rung of logic. And that's the logic right there. I did this manual mostly with CCW, with a Micro 850E. Any Micro 800 would give you the same. However, today, in this discussion, I'm going to use the MicroLogix 1400 for the logic just to make it different. And of course, the MicroLogix code is very similar to the CompactLogix code because we want just enough of the graphical user interface for the controller displayed here so you can see both of these simultaneously. Even though you click over here, it's going to block part of this. We can also make this a little bit smaller, and we could probably get rid of this, the palette, and then drag the whole thing over so they're both clear. The first thing you have to do, regardless of what controller you're using, you have to go in and create some tags. With the Micrologix 1400, you don't create tags. You get a predefined single element arrays. B3 by default is just a single 16-bit word. I increased in the properties the total number of elements to 13. The highest word address in file 3 is 12. So I've got 12 16-bit words. And then I wanted to use memory locations that were well away from B30, the first half a dozen, because typically these bits get used in your program for your code. I'm starting in B310, and you see I gave it a symbol of HMI input 00 toggle. There are underscores here that you can't see. It's HMI underscore IN00 INTOGGLE. And I did that. There's input 1, input 2, input 3, input 4, input 5. That's 6 toggles, bits that represent the toggle switch. And you can see them up here in the code. B3100 is the memory location that we're going to use to operate the toggle button over here in ignition. And here I want the HMI push button right there. See, 00 push button. I can take and grab that 0 right there and drag it up and drop it there. I can grab B311, drag it down to there and drop it. And then if I go back to B3 here, by the way, if you know Micrologix graphical user interface, you can click here and say on top, and it locks it on top. You don't have to go chasing around after it. I'll drag it down, and this bit right here is HMI input 0. I'll drag that up to the output, energized output for that ROM. We have a runga logic here that represents the wiring in the digital field device simulator. The normally closed toggles contact is wired in series with the normally open. If the toggle switch is in the normally closed position and I turn on B3110, then I'm going to turn on B312. Or if I put the toggle in the on position right now, then it's going to be maintained on. B312 bit 0 is going to be on. If I push the button, I'm going to open the normally closed, and B3120 is going to go off. That's the code that you have to have for every single input that you want to put into your digital field device simulator. I'm going to put that in and then come back. You can see that I have 6 in there, but they're all have the same address. I have to go edit the memory locations to accommodate the simulation of the different push buttons and switches. I can verify, and there I have my logic. I'm going to download, pick my controller, download. So here's our logic, and remember, these aren't actual inputs. We are using internal bits, and we're going to operate B310 0 through 5 and B311 0 through 5 with this toggle arrangement, 2-state toggle, and this push button. Let's go look at the tags. I'll drag this down. I'm going to look in the here, and I don't see anything in here that I can use. I have to add these 6 tags right here, B312 0 through 5, because remember, these we're controlling. We're going to have to add all of these tags. We're going to browse devices, go to B3, we click add, browse devices, and we use 10, 11, and 12. We could drag all 3 of those words in. I don't know if that's a good idea. Instead, I'm going to follow my own advice, and I'm going to pick B310 0, 1, 2, 3, 4, and 5. Throw them in there. I'm going to go to B311. I'm going to pick 1, 0, 1, 2, 3, 4, 5. Throw them in there. And I'm going to go down to B312 and pick 0, 1, 2, 3, 4, 5. And put them in there. I'm going to select all of these and I'm going to move them up into the Micrologix 1400 folder. You don't have to do that. Apply and OK. When I go to Micrologix 1400, and you see it's B310, which is the toggle. Over here, look, see toggle B310. This is a single device here. Before I drag in the tag, I'm going to double click on it. I'm going to come up and we'll look at this multi-state button customizer. Okay, I've got 2 states. Okay, this first object is a multi-state button. Multi-state button. See, it comes in with 3 states, and it's already by default hand, off, and auto. If you double click on that, we only need 2 states. I'm going to delete state 2. I have 0 and 1. That's a binary operation instead of an integer. And I can go in and change the colors, change the text to up and down. I'm going to let you do that on your own. Instead of it being off, auto, red, and white, I changed it to black with gray text and green with black text. Change the text to up and down. We're going to assign B310 0 over here, that toggle. I'm going to click on this, I'm going to drag it over here and drop it. If I change the state, see how this says up instead of down? Watch over here, the up and the down, when I change the state. Okay, that's the beauty of Ignition, is all of your objects, once you assign tags to them, they're active, whether you're in the preview mode or not. For the push button, we need B311 0. I can't drag it from over here over to here. I have to go down into the tag browser. We'll drop this down, and we want B311 0. Drop it on the push button. If we go over here and toggle B311 0, you see it changed shape. Well, watch the square over here, because remember I told you the border is all that changes. The whole square does not. Watch that green square. See, it got smaller? Watch it again. It got a little bigger, the border lit up. I don't particularly care for that, but that works for what we're doing today. We need to attach this to this input right here. B312 0 gets assigned to this multi-state indicator. We go down here to B312 0 right there. We drag that in here, and if we toggle up, well, we have to be in preview to do that. I'll go back over here and do it. I'll toggle B310 here in the controller. You see that went up and it shows input 0 on. I don't like that text size for that box. I'm going to go change that. We're not in the preview mode. I can double click here and open up the 2 states, and I'll run this up to 28. And see, we don't have the outputs in here. So we want to go back and bring in our outputs. We click on Add on the tag browser, Browse Devices, Expand Devices, Micrologix 1400, go down to the output file, and these are the 0 through 9, that's 10, 11, 12 words, 12 16-bit words that are allocated for outputs for the Micrologix 1400, which would include the expansion. However, we're going to expand slot 1, or it's actually slot 0, and then you're going to see the 16 inputs associated with word 0. We want output 0 through output 5. Bring them over to for provider, and then I'm going to select them again. Drag it up to Micrologix 1400 folder. Again, you don't have to have these folders. If you're working with just one controller, then you can have all your tags in one spot. See, I've got them busted up and organized. Apply OK. I'm going to go to 1400, and you see down there's the outputs. I want you to notice something. The format isn't the same. Notice it's instead of a decimal point, it's an underscore. But if I right click on this, go to edit tags, if I needed to, I could clean that up right here under OPC item path. If you look up here, the name that they brought in was, they needed some sort of a tag name because you don't have tag names, not really, in Micrologix. It's displayed as O:0_0_00, but the actual tag is correct. The format is correct. We'll say OK to that. I'm going to grab this and drag it up to here, drop it. Up to here, drop it to 2. And notice that I try to use nomenclature that has a match. I'm dragging in a tag with a 5 in it to a multi-state indicator that has a 5 in it. We're all assigned. If I go over here to my output file, right here, bring the focus over here, I put a 1 in, notice that output 0 goes on. If I go to 5, 1 enter, look down at the bottom, you'll see down here the output 5 went on. We can do the rest of them. No particular order, doesn't matter. It's always good to do this to check to make sure that you didn't put the tag in the wrong place. Now, I don't want to go back and toggle these off one at a time. What I'm going to do is I'm going to change the radix over to decimal. Then I'm going to go up here to where it says 63. 63 would be the first 6 bits are ones and the rest are zeros. That's, a binary value that there are no English words for, but in decimal it would be 63. I'm going to put in 0, and notice all the outputs go off. So that's an easy way to clear an entire word. I'll put it back to binary. I'm going to modify my Micrologix program to some logical degree. To do that, I'm going to have to go offline, to save, go offline. I could do some of this online, but the one thing I can't do is I can't modify the structure. So I need to add a new program file, and I'm going to make it 11, and I'm going to call it Digital Field Device Simulator. And I want to put all the logic in there. So I have this new file over here. I'm going to select that one, go down the bottom, Shift, Control C, go in here. I just copied this over from ladder 2 to ladder 11. I'm going to verify it. I'm going to go back to 2, and I'm going to delete all this. However, 11 won't run unless we put a JSR in ladder 2. Let's add that. Double click on it here and go to a text editor, JSR 11. When ladder 2, which is the only file that runs automatically in a Micrologix, when it executes, the first thing it's going to do is go to ladder 11. Now remember that the scan rate or the refresh rate on this processor is better than 1,000 times a second. Any discrepancy of you operating these buttons over here and looking at the lights, you won't notice it. I'm going to go back to ladder 2, and I'm going to put in some code to operate these outputs based on these inputs. I'm going to add that and I'll be right back. Okay, here's the logic that I put in, B312 0 through 5, that are simulating the outputs. Because keep in mind, whether the memory location has an I, an O, or a B in front of it, it's irrelevant. The only relevance of in and out, or I and O, is who's turning it on and off. In this case, we're turning it on and off from the HMI. I've got some logic here, and keep in mind over here, notice I got a JSR, jumping to 11. If I go here to 11, there's my logic to operate my HMI digital field device simulator. Go back to ladder 2, and we don't actually have to observe this, but this is a good spot. Let's turn on input 0. Okay, we need to put this in the review mode and turn on input 0, and you can see output 0 goes on. You look at the logic over here, and you can see it's true, true out, energize output. If I do 5 down here, notice that it goes, the output 0 goes off because I have a true if off here. Or push the button down and it accomplishes the same thing. Because remember that the button is wired in series with the single pole double throw of this toggle switch. So here's logic that we can use. I'll turn this back off. And the only thing that's not on is input 5 here, because that's a true if off, and it is off. If I flip this up, that's false, and it'll never go true unless I hit this push button. See, it goes true. Let's keep this simple. We do input 2, and you see that turns on output 1. If you follow over here, input 2, output 1. If we turn on output 3, it doesn't turn on anything because it also needs 4 on. So if we turn on 4, output 2 is on. Or we can turn 4 back off and hold the button down and accomplish the same thing. This is your actual process logic here. This is your machine logic. And this is just logic that simulates that digital field device simulator hardware device through the HMI. Okay, we finished our digital field device simulator over here. We made it a floating window, a pop-up floating window. I resized it and brought it over here right next to and on top of my MicroLogix 1400 logic. This is looking at the button logic. Let's go to the process logic and expand this up and go in and turn on input 0 with push button. You can see the output went on. Or we can take and maintain it by just pushing the toggle to the up position. It'll stay that way. Typically, where this is important when you're doing your lab projects is if you have a conveyor application that you're working with in your manual. I use a lot of conveyor applications because they're easy to follow and visualize. If you have a photo eye that's looking for cartons, and if a carton is on the move and passes by it, if you use the toggle, which you do on most simulators, and you forget to turn it back off, then you may wonder why your logic's not working correct, when in reality, instead of using a maintained on, you should have just pushed the button, and if anything else, you're going to lose interest in this, let go of the button, and the carton has gone by the photo eye. That was the whole intention of having a 4-state input field device simulator. Right now, it's maintained off. This is maintained on. Maintained off. Momentary on. Maintained on. Momentary off. Just like that. One last thing with our window here. Notice that the window, I have it, the size changed. It's just enough to contain these 6 digital field device simulation. The last thing I want to do is point you over to, go up to the window itself, right here, and look at the properties. Closable, maximizable, resizable. You want those selected. You want to make sure that it is a floating, see down here, dock position. You want to make sure it's floating before you launch this. So we're going to launch it. You'd go up to Tools, Launch Project, Launch Windowed. You have to log in. You can't see that. We'll run another screen. I'm going to minimize this. We're going to make this a little bit smaller. And then I'm going to drag the window that I created over here. The pop-up is not the Windows window. This is the Windows window. Once you launch it, you're going to have to collapse it down. It's just about the size of, and there you have it. There's always one more thing. I brought up a project here that you're going to do later on in your lab project. And this is a set of conveyors that you're running. And if you look at the, if you want to call them tag names, or if you want to module define tag names, or pointers, for instance here, input :0/4. You're not going to use that. Instead, you're going to use whatever address you have assigned to this arrangement down here, which in the project that we just went over would be B312.0, or that would be B312.4. So in your lab manual, if you want to use this digital field device simulator that's running as an HMI, then instead of using the actual input pointers that begin with an I:, you need to use B3:12/4 for input 4, 0 for input 0, and so forth. So you have to, it's on you to translate that when you're doing your lab projects, because you're using internal bits and simulating them as your inputs. Keep that in mind. I mean, go over this again and again in your head before you start these lab projects if you're going to use this digital field device simulator from the HMI.